So welcome to the second video, which is going to cover the on-delay timer programming in RSLogix. So here we are going to first start creating our program here. So since this is going to be the first video, we are covering the on-delay, the timer functionalities here. I will construct everything from the scratch, but in the next video, which is covering the off-delay timer and retentive timer in the third video, I will just go over and revise what we have done here in this first video, which is going to covering the on-delay timer here. So the first section is we will start putting our let's choose the red. And then we start with our input column 0-4. And then this is going to be our switch 1. So just give the description name as switch 1 here. So the second thing is going to be establishing our timer here. So as you can see, you have user, you have bit, and then what we have here is timer on delay. You need to choose this one. In the next video, we are going to choose timer off delay. And then the last video is going to be covering the retentive timer on delay here. So the first one is going to be timer on delay. As you can see, it's going to be popping up on the right-hand side of this first one. Here, we have timer on delay. So what we need to do here is to give our timer as T4 column 0 here. And then our name could be just simply timer. You can give any other name as long as you are consistent with your naming later in the video where you name your EN bit, DN bit, and TT bit, where you can actually understand the connection between these different inputs. So you can ask, why do we use T4 column 0? That is because, as you can see on the left-hand side, in data files, we are going to have our T for column 0. So this is going to be your table here. If you remember the input tables we have used in the earlier semester, they are written here. Our timer will be here. On the other hand, the next week after the spring break week, we are also going to cover counter. They are going to be here. So just get familiar with the usage of these tables here. So our table will show the EN bit, TT bit, DN bit, our time base, our preset value, and our accumulated value here. And then you can also find some descriptions we have here, which is what we have named as timer at the moment. So our time base will can get 3 different values to 1 second, 1/100th of a second, and then 1/1000th of a second in this program. I remember in the book, we have also 0.1 second, but in here we don't have that availability. We only have 0.01, 0.001, and 1 second here. So for this example, I am going to choose 0.01 second here. So each bit is going to count as 0.01. On the other hand, we also need to choose our preset value soon. And then once you start counting on in the timer on delay, our preset value will be compared with our accumulated value here to change the values on the EN bit, DN bit, and TT bit. Don't forget that on delay timer is going to start timing when the input condition becomes true, which is here. So when this one becomes true, our value will start counting. You will see soon. On the other hand, in the next video, you will see the off delay timer that is going to begin the timing when the input condition goes from true to false, which means that this is going to be false it's going to start with on, but once you turn it to false, this accumulated value start counting the time here. So here we can give this one as 6,000, let's say. So which means that our preset value is 6,000, which means that 6,000 times the time base, which is 0.01, our preset value in terms of seconds will be 60 seconds. 6,000 times 0.01 is going to give you 60, which means that 60 seconds. So the next thing is going to create our second rung. We go back to user and then establish our first functionality here. To connect this one to our timer, we need to name as T4 column 0 dot en. This is going to be our en bit control here. And then you can click enter. If you don't write in the description anything, you will see the description is named as timer. The reason why it is named as like this, because our T4 column 0 is connected to this T4 column 0 in this timer function here, which is timer. This is also timer. So you know this en bit is connected to this second rung we have as an en bit here. And as an output, you can just simply choose this one. This one will be output column 0-0. And then the first one is, let's say we choose green light. This is our description. You can choose any other name. These are just hypothetical names. There's no connection between the lights right now. So we also need since we have our en bit, we also need tt bit and dn bit in our PLC here. So what we can do here is we can choose the second rung, just copy. So copy this one and paste here. Then change the name of this en bit to tt bit. But we also want to change this one, so you can change this one to 1. Actually, let's see. We can change the description name to yellow light. So we have green light, yellow light. This en bit is connected to green light output. TT bit is connected to yellow light. Again, since we already have the copy, we can just paste here. Then this one is going to be dn bit here. Don't change the name. They are all connected to our timer here. Because T4 column 0 here we have. This green light. Did we change this one? Yes. So this one will be 2. And then we can name this one as red light. So now we have our timer on delay. Time base is 0.01. Preset value is 6,000 and accumulated value is 0 since we have not opened our switch here to trigger our functionality here. Once we are done with here, we need to verify our project. And then you can save this one to our desktop. And then you can name this code as, let's say, timer on will be, let's say, timer on example. Maybe. Okay, that's going to be TON example. So once we are done, we save it already. So what we can do here is we can close it, if you remember, and then we open our RSLogix emulate here. So file, click it, Go to your desktop. This is the one we created. Station number is 1. Then once we are done, we can come back here, and then this is the one we created, and just open it. So here, let's make it bigger. So what we need to do here is comms, and then we click who active go online. Then we choose this MicroLogix 1100, as we have done previously in our lab exercises. So right now we are in remote programming. To start, here we click run, click yes. As you can see, it becomes online right now in our program, and then this is turning here. So to understand what is going on here, let's see, actually, we are going to have the timer on delay as true, and then our accumulated value will start with 0 first. And then whenever, before hitting the preset value, our DN bit will be 0. On the other hand, our PLC will write 1 to EN and TT bits. So you can just print out this one while watching this video to understand the difference between this 0 and 1 of this DN, EN, TT bits. If the on delay timer is true and accumulated value pass our preset value here, which is, we have 60 seconds. If you remember, the 6000 bit is multiplied with 0.01 second, which means 60 seconds we have total. Whenever we reach the 60 second in the accumulated value here, this PLC is going to write 0 in our TT bit, which is yellow light will be close. Our TT, our EN bit and DN bit will be 1, which means that EN bit will be 1, DN bit will be 1. So which means that we are going to open the green light and red light here, but yellow light will be close whenever this accumulated value pass the preset value when the switch 1 is open. On the other hand, if everything is, this one is close and false, everything will be shut down here. But the first thing is we can start with the on delay timer. So I'm going to toggle this bit, and then this accumulated value will be less than preset value at the beginning, since we are at second 0, but we need to reach second 60 here to trigger this condition 2 we have here. But first one will be here. So our PLC is going to write the DN as 0, EN and TT bit will be 1. So we toggle the bit. Then as you can see here, our accumulated values start counting and then trying to reach this 6000 we have as defined here. So our TON is true, accumulated value is smaller than the preset value. Our DN bit is 0. As you can see, DN bit is 0. Our EN bit and TT bit is 1, which is 1. So this is what it means. So what we need to have at the end, when the accumulated value passes this preset value, our TT bit will be 0. So let's wait until it reaches 60 seconds. Okay, it is almost there. We reached the 50 second. And here is, boom. As you can see, our yellow light is closed, and then our TT bit is 0. The reason is why we have yellow light is closed. So our DN bit is now active with the red light, which, as you can see, EN bit and DN bit is 1 right now. And then once we close, we toggle the bit back, boom, everything is 0, and then our accumulated value will go back to the 0 as well. I hope this makes sense. In the next video, we are also going to cover our off delay timer, and in the next video, we are going to cover the retentive timer here. So see you in the next video.